Hi, in this video, I'm going to show you how to use reusable workflow with multi-environment at GitHub Actions for AWS Platform Engineering. As you see in this PPT depicts my demo. Here, as usual in my videos, I'm going to explain you my complete demo into two parts. In the first part, I'm going to walk you through the design and how does this solution is been set up and how does it works, okay? So that's the first part I'm going to walk you through. And in the next part, I'm going to show you how does we can set up this configuration and achieve the required demo at the end. All right. So before I walk you through the first part of a demo, a kind request, please do subscribe my channel. That would really encourage me a lot. So with that note, let's directly jump to the first part of the demo, right? So before I walk you through the first part of a demo, saying like, how does this design works? Let me quickly give some insight about this setup. Okay. So here we want to manage cloud platform with using infrastructure as code technologies. Okay. So here I'm using GitHub Actions. In the GitHub Actions, we are using reusable workflows, multi-environment to satisfy the need of releasing to the multiple environments of your enterprise, IT workloads maybe, right? So like development, test, and production. And here we are also using Terraform Cloud as a remote state file storage and also remote execution, the service. All right. And finally, we achieve, how we can, bring out the required infrastructure of multiple environments like dev, test, and production. Okay. All right. So that's the basic, the brief about this solution, but I'm going to walk you through the in details in the next. Okay. So let's go to the next one. So here I'm going to take you to the next part of the demo. So here, first thing, okay. So first one, we want to set up the GitHub. Okay. So basically, GitHub is a service where we are storing the GitHub actions. Okay. So basically, once you have a GitHub, you will be hosting your infrastructure as code, infrastructure as a code, repos here, right? Which contains your GitHub action definitions and the Terraform file definitions as well. So where in the Terraform file you're going to explain like how your infrastructure has to be look like across the environments like dev, UAT, and production. All right. So this is what the first step it tells about. In the next step is whenever you have the source code, right? So the source code will the one repo, the GitHub repo will be having the GitHub actions. Okay. So basically, that's where the next part comes. Is the GitHub action is the CI/CD tool native from the GitHub, right? Which actually helps you to achieve the required CI/CD workloads at your source code. Okay, so basically, you want to continuously integrate something, continuously deploy something. Okay, so those are all the tasks which are called as a CI/CD. But GitHub action is kind of very matured one, and currently there is a word called GitOps. Okay, so basically GitOps is nothing but whenever you write some code, you integrate some code to your GitHub repo via raising a pull request or making the pull request merged against your GitHub. Automatically the respective source code will get invoked and it will be deployed into your infrastructure. Okay, so that's what we call it as a GitOps. If you want to know more about GitOps, maybe you can watch my previous video where I have explained in depth about the GitOps. All right. So basically, you have a GitHub, you have hosted your source code, which contains GitHub action workflow definitions, and your Terraform infrastructure, Terraform as infrastructure as a code technology. In the sense, infrastructure as a code source has been kept here, and you have defined the GitHub actions now. Now, once you have defined the GitHub actions, so in the GitHub actions, we're gonna specify a special. There is a special feature from the GitHub actions called workflow. Basically, workflow is something like it's something like a elevated feature where with using that you can orchestrate step by step workflows. Okay, and that's what workflow gives us the capabilities. This workflow basically will use this workflow can be used at the environmental level. Okay, so here on the GitHub actions you can set the environments like maybe dev, UAT, test, production, something like that according to your enterprise conventions. Okay, so here we will set the environment, for example, like dev, and that environment dev will have the connectivity to the Terraform cloud. So Terraform cloud is again it's a HashiCorp service which actually provides the remote execution and the remote Terraform state file storage purpose. Okay, so basically we are using here GitHub actions. In the GitHub actions we have defined the workflow which will invoke our series of workflows according to the environment. in the environment we have specified saying like, if this is the environment, we need to have a workspace in the Terraform cloud which actually stores and executes the Terraform state file. Okay, so that is where Terraform cloud is. Once you have the Terraform cloud, remote execution happens, you have the your up and running infrastructure in the your AWS accounts or multi accounts AWS environment. Okay, likewise, this flow can be replicated across dev, once you are done with the development. For example, at the first stretch, your developers will be developing on the development environment, like they will be coding the Terraform code, they will be writing some Python code, maybe YAML files, etc., etc., okay, which actually mean to spin up the required infrastructure at your first environment, that is a development. Okay, so once you are done and you're happy with whatever the testing you have done in the development side, you're going to create a pull request and merge it against the test environment, right? So, and the test environment is nothing but, it's a second, it's a pre-production environment where you will do a user level acceptance testing, right, with using TF cloud again. And finally, once you release the same code to the the next environment, that is test, you will have a up and running test infrastructure as well. Okay, finally, finally, when you are good, when you are all set, then you want to release to the production. So that's where you will redirect that workflow to run on the production environment, right? And with using the dedicated TF cloud workspaces, which actually spins up again a final green working production workloads at your AWS accounts. Okay, so basically this is what I'm going to show you. Okay, so if I can reiterate, so we're going to have a GitHub repo. In the GitHub repo, we're going to keep all our workflows, that is GitHub action workflow files and all. And finally, we will also keep an infrastructure files, that is infrastructure as a code file using Terraform. And this Terraform will be executed on our Terraform cloud workspace. So I have a Terraform subscription, Terraform cloud subscription, and I also have a Terraform workload, a Terraform workspace, where we can point this remote execution and also remote state file storage. I'm going to show you how we can do that. And finally, when you bind all these together, you're going to achieve the required, reusable workflow. So here, this workflow, a single workflow is orchestrating multiple environment, right? Like dev, test, and production. Okay, that's what I mean. Reusable workflow for multi-environment infrastructure provisioning. Actually, here we are provisioning AWS infrastructure, right? Which is nothing but platform engineering. Basically, you are managing the AWS platform for your enterprise workload hosting. Okay, so that's what this demo is all about. So basically, this is all about the the first part of my demo. I'm going to walk you through the next part, that is how I set up these at my AWS account. Okay, so basically, I have my AWS account. So this is my AWS account. Let me show you. So this is basically my plain AWS account. So on this AWS account, I'm going to show you how we can replicate that reusable workflow can be used, and how we can mimic the dev UAT, dev test, and production releases, right? That is reusable workflow with multi-environment CI/CD task. How we can achieve that on this AWS account. Okay, that's the first thing. The next thing, for this demo purpose, I have created a GitHub repo. Anyways, the files and folders present in this GitHub repo will be shared in my another dedicated GitHub repo, and the link will be shared. You can find these code files and folders from there, and you can find the repo link in my GitHub in this video's description especially. All right, so this is the core place, this is the destination place where all our CI/CD tasks have been defined and consumed. Okay, all right, so this is, I have one single GitHub repo called Git Reusable Workflow name. In that one, I have the two branches. I'm going to show you two branches. One is the main and the feature branch one. Okay, so feature branch one, I consider this as a development branch. Main branch I will consider as a final branch through which you can release to the development, through which you can release to the test and the production. Okay, so that's how I have set my GitHub. Okay, so in that GitHub repo. Okay, so in the GitHub repo, you have two branches, right? And the branches is hosting these codes. Okay, so basically, and one more thing. So I'm going to take you to the next part of this. The next thing that you need to know on the GitHub is GitHub Actions. Okay, I'm going to walk you through the GitHub Actions. So under the GitHub Action, you see workflows. Okay, so here there is a reusable workflow. So that is IAM roles, S3 bucket. Then you have the reusable workflow, which is actually called workflow. That is apply TF, right, and plan the TF. Okay, basically build the TF plan, apply the TF plan. Okay, so these are the reusable workflow or called workflow. Okay, All right. So this is the GitHub action. So I'm going to walk you through the how you can set up these, the called workflow and the caller workflow. I'm going to explain what is these in a second. Okay. So basically, this is the GitHub actions. I'm going to I'm going to take you to the settings. So settings is something like which is high privilege task that you can do on the GitHub GitHub repo. So this will be available only for the owners or the the contributors of this GitHub repo. So apart from that, nobody will have the access to the settings. Okay, remember that. So basically, if you see in the general, there's a left side pane options, collaborators, moderators. Okay, basically these are access level, access management features. I'm going to go back to the code and automation. So in the code, you see the branches, tags, actions. Okay, so in this action, you can see the general runners. What is basically runners? So GitHub action is nothing but what? Basically, GitHub action is nothing but it's a CI/CD machine which is actually doing the orchestration of the continuous integration and continuous deployment. Okay, so this is the machine which actually runs your or the executes the code from the GitHub. Okay, so it will clone the repo from the GitHub. It will make the everything in the proper shape and finally execute those files. And finally, you will see the GitHub action being invoking your the executable file like Terraform, and which is eventually causes the infrastructure spin up. Okay, that's where the GitHub action machine does all about. So I'm going to show you the GitHub runner. So I don't have any GitHub runner. I'm just using the general GitHub actions. All right. That's the one thing. And I'm going to show you one more thing, that is environments. Okay, which is the core part of our demo. So here in this demo, I'm going to show you only two environments, even though I showed you three things in the first design PPT. But this is the same thing you can replicate even for the production environment as well. So how do you create is you're going to go to the environment of the settings. You are in the settings, you went to the environments, then here there is a button called new environment. Click on that, right? Here you're going to give the name of the environment, for example, prod, right? And configure it. And when you're configuring it will ask you two things, whether you want to keep some reviewers. Okay, for example, you can keep the reviewers, for example, right? I'm going to keep myself as a reviewer here. I've already done for the UAT. I'm going to show you how does that reviewer works in the environment as well. In the waiter also, in the wait timer also, you can set it if you want. Right, and in the down the line, there is a deployment branches. You can specify which branch can deploy on this one as well. Basically, I have kept all branches. Okay, I have kept a feature branch. When I will show you what did I do. And in the environment secrets, you can keep the environment secret. Okay, so this is very secure. You can keep your environment secrets here without any hesitations. Okay, so basically this is how I created the environment. So I'm going to show you back. If I open the UAT, right, so this is the actual configured one. I'm going to show you how does this works. So in this one, I have added the reviewer like myself, right? In the in the deployment branches, if you see, I have pointed UAT to main branch, which is the final branch. Okay, only through the final branch you can release to the UAT environment. That's what it means. In the secret, I have pointed a secret, that is TF API token. So basically, TF API token is nothing but that is something configuration that you can get it from the Terraform cloud. I'm going to show you that in a minute. So basically, to get the TF API token, so let me take you to the Terraform cloud. So basically, this is my Terraform cloud. So if you go to the app.terraform.io, you need to have a subscription to the Terraform cloud. Then only you can create the organizations. So here I have an organization called cloudquicklabs, which is my channel name. In the channel, in this organization, so basically on this cloudquicklabs organizations, I have two workspaces, that is AWS backup. Since this is just a very generic, I have given some, I'm reusing the previously created workspace, that is AWS backup, right? So this is the workspace, and in this workspace, we have also configured the environmental variables. Okay, I'm going to go to the variables. In the variables, you see in the workspace variable, we have added AWS secret underscore access underscore key, which is basically, so this is the syntax that you need to maintain to connect to the AWS with using API mode. Okay, so if you want to connect to the AWS, you need to have a IAM user with the programmatic access on your AWS account with required permissions. Okay, so basically you create IAM user, give him a required permissions, and then get the required access key and the secret, and come here and place it something like this. Okay, so here you need to keep the secret key exactly like this without any small mistake. Okay, even you cannot miss the spaces. Basically, you need to create a key with this syntax, something like this. If you go here, create a key something like this. If I can copy, let's say I'm creating the access key, what you do is add it here, give the value, right, make it sensitive, and that's all. Go ahead and create it. So you should mark it as a environmental variable, so not a Terraform variable but environmental variable. Make it sensitive. If you want to provide a value here, make the description and click on the save, which will eventually create two workspace variable, something like this I created. So basically Terraform uses these the keys and values to establish connection to the AWS, and from there it does the actual job, that is spinning the spinning the the required infrastructure, modifying the infrastructure, right, destroying the infrastructure, all been done with this access, okay, with this access key and the access secret. All right, so basically this is the the environmental configurations. Now I'm going to show you from where I get the TF API token. Okay, I have already explained this in my previous video. If you would like to know more about how you can create a TF API token, please do watch my previous video. All right, so to create a TF API token, you need to go to your user settings, click on the user settings, and here you see there is a button called tokens. From here you can generate a token. So if I can go down, so I have a Terraform login. I have created an API token, something like this. Click on this one, give the description, and create an API token. So this basically, this is the token is nothing but it's an API token of Terraform, through which through with using that GitHub Actions communicates to this Terraform workspace and this Terraform organization and Terraform workspace basically. Okay, so that's the basic logic behind this one. So that's all about the TF API token. How did I add it? There is an add button. Click on this one. Provide the syntax. So here you need to maintain the same API name. The key name should be exactly something like that. That is TF underscore API underscore token, something like this. And whatever the token that you get from here, you have to put it in the secret value and add secret. So that's all. So eventually, finally, you will end up with adding the secrets. Okay, so like this I have already did for development as well. I did same thing for the development. Right now let me delete the production because I don't want okay, basically it is asking for two-factor authentication. Maybe I will do that. Okay, all right, so let me delete this for now. I'm going to delete this actually. Okay, all right, sorry, I have typed wrong password. I'm going to delete this. Okay, all right, I'm just deleting it off. Basically I cleaned off the unwanted environment basically. Okay, similarly I did the same configuration in the environment. Okay, so basically, yeah, so that's what I'm going to help you. I'm trying to help you here, how you can set up the multi-environment that is needed for enterprise grade. Okay, so basically this is how I did it. Yeah, okay, so so we have covered the required things here. Now I'm going to take you back to the code level. How did I set these folder structure and what is the thing that I have kept in the folder structure? I'm going to walk you through that and finally we see how does it works. Okay, so what I did is I have taken this I have downloaded this, or I have cloned this repo in the Visual Studio Code. So you see the same code. You can forget the name of my the repository because I have renamed my repository after that. So basically this is the same repository that I have cloned here, and that's where you see the folder structure. Okay, so basically GitHub Workflows, IAM roles, and S3 buckets. Okay, all right, so I'm going to expand that so that you are aware of these. You see workflow contains 4 files, and these are the 4 files. And if I go back to the other folders, for example like this, right, IAM role, so basically it contains these many, like nearby 6 files. So if I go here in the IAM roles, so it has the 6 files. Okay, now we are here. So basically what it did is you have got a knowledge of how to set up a repo, on the repo how you can set up the how you can set up the multi-environment. So till now we have seen only setting the environment. So first you will configure the environment on the GitHub action or on the settings of your GitHub repo, basically on the GitHub actions only. So then we're gonna see how did I configure the the reusable workflow, and finally how does this GitHub reusable workflow connects to the Terraform cloud and achieves the required the CI/CD job or GitOps jobs to achieve the the AWS infrastructure provisioning. All right. Okay, so let me go to the code walk. So now I'm going to help you with the code walk. Okay, so be patient, and I'm going to cover the code very top level and very quick, quick code walk. Okay, and after that I'm going to show you how does this works and helps us to spin up the AWS infrastructure. Okay, so under the GitHub workflows, I'm going to show you only one reusable workflow called IAM roles. That is 01-IAM roles, right? So here, if you see, so this is the definition of reusable workflow. Basically, as I explained, workflow is nothing but it's a feature from the GitHub action, and that, as the name says, this workflow will manage the orchestration of multiple tasks. It will help you to deploy something one after the other, or based on the conditions. Okay, so that's what this workflow is helping you, and that is what we need to achieve the multi-environment deployment. Okay, so reusable workflow is very suitable option to achieve the multi-environment deployment. That's what my inference is all about. So here we have given the name. Okay, so this is the syntax. Reusable workflow has its own syntax that you need to follow. Maybe you can see the GitHub action, the public documents, and try to explore about it. Here we have given a name, that is the name of my reusable workflow, and this is the same name gets replicated in your GitHub actions. If I go to the GitHub actions, in the GitHub action, you see the IAM role. So this is the name that replicates from here, right? Okay, and then after that, I have added some condition called on. So as you know, GitHub action in general GitHub action files, we declare some on. Okay, nothing but on tells you when does this workflow has to be run, basically. Yeah. Since this is a reusable workflow, it will get here I have added workflow on dispatch, in the sense whenever you want, invoke it. That's what workflow underscore dispatch is mean. Okay, so under the jobs, okay, so it has a jobs. You see I have declared multiple jobs under the jobs. So this is where we bifurcate the task between the environment. Okay, so one is you are planning something on the development, you are deploying something on the development, then finally you will have the definition of plan on UAT and deploy on the UAT as well. So you have two environments been bind together, that is dev and the UAT. Okay, so that's where the differentiation comes here. So in the plan dev, so what does this plan dev job does? This plan dev job is actually runs a Terraform plan command on the development environment and creates a draft of the infrastructure with using Terraform infrastructure as a code. Okay, so basically this is what it does. So here we have added a condition just to check if the GitHub repository reference is or GitHub branch reference is something like this feature branch 1, which is actually a development branch, which I denote, right? So if the branch is something like that, it needs to run a Terraform plan, right, on the development environment. Okay, so how does that been happen? So if you see here, so the workflow actually whenever you run the workflow, basically it closes the repository, and it closes the repository belongs to a particular branch. Okay, that kind of capability it will give. So basically that's the reason you will have a keyword called users, and there you will give a reference to your GitHub repository, right? GitHub repository, Terraform or other reusable file. Okay, so as I was talking about called and the caller workflow. Okay, so basically caller and the called workflows. So here 01-IAM role.yaml file is a caller workflow. It's calling another workflow, right? So here 01-IAM role.yaml file becomes a caller. It's actually calling the another the workflow file. Okay, that's the reason it has been declared as it has been denoted as a caller file. So basically this is a caller file. It is calling a called file called AWS underscore TF plan, which is nothing but which is sitting in the same GitHub flow. So if you see here, this is the plan file. Okay, and this is the same template we're going to use it for dev, UAT, and production. Okay, because dev, UAT, and production are the environments which are mirror image of each other. Okay, so they should look alike. Okay, maybe during the development or during the test pages, the dev, UAT may be changing here and there, bits and pieces, but actually under the hood their skeleton would definitely look alike. Okay, that's the reason we need to use same code across the environment. Okay, so here we are planning on the development, and it will call, so this caller workflow will call this called workflow called AWS TF plan, which is sitting here in the something. Okay, and this is specially pointing to a @ future branch only. Basically, what does this mean? In the sense, this workflow will actually download under the hood, the GitHub action will download this complete repository. It will go and execute the file present under that repository and particular branch like this, and try to execute with using these environmental variables. So here I'm using path called IAM role. So under this complete repo, there is a path. Okay, so if you see there are paths, that is .github IAM roles and S3. So here we are telling IAM role. So you go and run this IAM role. Okay, that's what I mean here, right? Path is IAM roles, and then in that IAM role we are using a parameter variables that is called development.tfr, that is dev.tfr. Basically, since this is a development environment, we have to run the dev.tfr only. Okay, I'm going to walk you through this as well in 1 second, but before that I'm going to complete this. So here we are also declaring the environmental variable, that is to which environment this reusable workflow has to be run, that is in the dev, right? And finally we are also passing a secret, right? So here we are downloading the secret which we have kept on the development environment. Okay, so from the development environment we have kept a TF API token, and that will be added as a secret to this secret value, secret key, and this will be given to this Terraform plan. Okay, so basically all these environmental variable plus secret will be fed as an input to the AWS TF plan.yaml file. Okay, all right, so this is how it works, and I'm going to take you to the plan deploy as well. Basically deploy is nothing but it's apply only, that is a Terraform apply. It's exactly same like what I explained in the dev on the plan dev, but little bit changes. Okay, so here we have added a condition called needs. Basically condition is nothing but when the plan dev is success, then only deploy underscore dev has to run, or else it has to skip. It act as a if condition here. And then we are also giving a users variable, that is, and this is pointing to the same branch, but here it is pointing to the AWS underscore TF apply file, right? And that is basically this is the file which actually runs the command, that is Terraform apply. This is the command which actually runs Terraform plan. Yeah, and here the environmental variable remains same as it is, since I'm using very generic one, and this is only purely demo purpose, but in production maybe the environmental variable might increase, the credentials might increase according to your needs. Okay, all right, so basically this is how Terraform plan and apply reusable workflows are being called by the caller. Okay, so now hope that you understand. So here caller is nothing but a file which actually calls the another file, it becomes a caller file, and the file which is being called by the another file is called as a called file. So here the plan and apply files are called files. Okay, all right, so the same definition is been replicated, but here environmental variable changes and the secret changes. That's all the difference is here. Okay, so if I walk you through the plan that you add, so here again we are doing the if condition, but here if you note we are pointing it to the main. So why we are pointing to the main? Because main is a stable branch, and the code which comes and gets merged into the main is very mature code, which is tested code. Okay, so that's what we want to release to the test environment, and that's the reason we point users to the stable repository or stable branch within the repository. So remember, so always the the production and the pre-production environments will always point to the stable branch within the repository. Okay, that's the reason my logic is here. And then we are also defining the variables, that is the environmental variable. Here again I'm pointing to the IAM roles, right? Then here the different changes. Okay, here we are using UAT related variables, that is a Terraform variable. Similarly here also we are pointing to UAT. So basically earlier I showed you the configurations related to the development environment. Here the configuration is related to the UAT environment. Okay, and the secret eventually. Okay, all right, so now I'm gonna take you to the IAM roles folder. Okay, which is we have declared as a path in the caller in the caller caller workflow, basically caller workflow. Yeah, so before that before I walk you through the IAM roles, I'm going to show you quickly the Terraform apply and the plan. Okay, so basically Terraform apply and the Terraform plan and the Terraform apply files are the called files of the caller workflow. Okay, so the syntax of this called files looks something like this. You see it has a name, called apply tf file. Okay, so that's the name gets replicated here, apply tf plan. Yeah, and then in this one we also have on, that is on when workflow calls it. If I go back to this one, okay, so let me open it in 2 tabs. So here we have called workflow dispatch, on workflow dispatch, and this gets triggered workflow call, in the sense whenever there is a call happens from here, then only this will run. It will not, then or else it will not run. So that's what it means. In that one we have segregates some variable into inputs and some variables into secrets. All secret will be listed here secret because the GitHub Actions thinks secret to be very secure tokens or secure string. They have to be securely handled. Okay, so that's the reason GitHub Action discriminates between these two. So word is very wrong, so sorry, so this is not a discrimination in the sense it tries to keep two things different. Okay, one is it is okay to not to keep these variables as a secure strings, but the secure string has to be transferred over the internet with a very secure manner. Okay, so that's the reason it has a two ways, that is input is considered as a variables and secret is considered as a very secure string which is need to be protected. Okay, so in the input part, so if I go back to the here, we have given input like path, tf var files, environment, right? So all those will be listed here. One is the path. You see in the path you have the description, tf version. So basically tf version have been declared and it has a default value. Okay, so if you bifurcate between these two, this does not has a default value, but it has a default value. Wherever there is a default value is not been added, you must feed the value to that from here. Okay, so the flow will come from I am role to the tf apply or tf plan. Basically both are same. I'm just walking through the apply because plan is the subset of the apply basically. Okay, that's the reason I'm just directly going to the apply. Okay, so if you understand apply how does it work, then the plan is eventually you understood. Okay, then let me go to the next one. So here we are adding the giving the environmental variable. Basically default value is null. tf var file, there is no default value for here, and the secure string. Okay, so there is also, it is required and it is mandatory secret here. Okay, so that's what we define in the workflow inputs and the secrets. And then we go to the jobs. Okay, so basically job is the whatever the job definition that you write here is exactly like normal GitHub Action workflow definition files, as simple as that. Okay, so here apply. Okay, so apply plan, so basically that's the name of my job. It will run on a Ubuntu, that is Ubuntu latest. And here you see the environment. Okay, so here we are setting the environment in the sense on which environment it has to run, that is input.github, right? Okay, so input is what? So input is nothing but this input. Okay, so that is being fed from here, right, from the workflow call, and that's what we are pointing. So how we are getting referencing that input is something like this, like a dollar double flower bracket open input dot github underscore environment and closing the flower brackets. Okay, that's how you retrieve the environmental variable here and it put it across. Then you have a defaults. In the defaults we are adding some runs. It should run on a bash, and the working directory is the basically working directory is nothing but path. When GitHub Action runs, I said you GitHub Action basically clones the repo, it executes the files locally, right? So while doing that, we are telling the GitHub Action, hey GitHub Actions, so you have to do a cd to this path and then try to invoke my files. Okay, that's what this working directory means. Yeah, I'll go to the steps. In the steps, basically we are doing the natural or the normal steps of your GitHub Action. Okay, that's what I was telling. So first one, GitHub checkout. What does this mean? So GitHub Action will actually check out your code from the repository, right? And it currently using the API version action checkout at the version rate 3.1.0. Yeah? And then I'm doing some certain magic. Okay, this is very intelligent way that I have figured out. Basically, since I'm executing the code remotely on the Terraform cloud and also storing the state file in the remote Terraform cloud, it was very difficult for me to figure out a way how I can pump or how you can make sure that when I'm releasing to the development, I should invoke only dev.tf files. When I'm releasing to the when I'm releasing to the UAT environment, I should use only UAT.tf file, TFR files. When I'm releasing to the production, I have to use only production.tfr files. So that was a big challenge for me. So how did I came to know is I found out a way. I found out a task on the GitHub Action with a name called for example, when the GitHub Action checks out this complete code, it will have this same syntax, that is dev.tfr, production.tfr, uvat.production.tfr, variable.tf, im.tf, main.tf. Okay, so when you execute this folder with using GitHub init, GitHub plan, and with using Terraform init, Terraform plan, and Terraform apply. So basically, as you are aware, there is a difference between the variable.tf and the .tf var files. Okay, so variable.tf file is a file where you actually declare the number of variables that is required to run the Terraform code present in that directory. And whereas the .tf var file is the file which actually contains the values of the variables that is being declared in the variable.tf file. Okay, so finally the input to the natural or the normal Terraform file or the Terraform file where the infrastructure has been declared will be fed by the tf var files. Okay, so by default Terraform does not uses dev.tf file until you use it in the command. Okay, so that's the reason there is another option. There is another option that the Terraform gives us is, if you are adding a tf-var file with the name like .x.auto.tf-var file, then automatically that tf-var file will be considered as the final Terraform var file that has to be used to compile the Terraform code. Okay, so that's the reason my idea here is, whenever you are releasing to the respective environment, I need to make the respective dev.tf file name has to be changed to the dev.auto.tf-var file. Same thing for uvat.auto.tf-var file. Same thing for production.auto.tf-var file. Okay, and that's the reason I have added a logic in the GitHub action which will automatically or dynamically change us the file of this respective dev.tf-var file to the auto.tf-var file. For example, I am using the Linux command called mv, which is actually renames the file. Nothing but, for example, if I'm currently running on the development environment, I need to change the dev.tf-var file to dev.auto.tf-var file. Okay, so that's what it does. So basically this is the workspace. Okay, in the workspace we are going to the workspace is nothing but it's a path within the GitHub action where your code is being cloned. Okay, and finally you are putting the / and getting the input path. So the input path is nothing but IAM roles. After that you are getting the input.github environment, that is a development. So here we are choosing the development, for example dev.tf-var file. So basically it construct the path of the GitHub action, okay, machine, and that file has to be renamed into auto.tf-var files. Okay, that's the basic logic, and it actually works very brilliantly. Okay, and that's the idea stuck in my mind, and I have done it here, and it works. I will show you how does it works. Okay, so that's the change file name task, and then we are doing the Terraform setup. Okay, so we are doing Terraform setup using this APIs. And finally, when we are setting the Terraform environment, we are also declaring the version that you need. Here I have declared the latest version. Maybe you can choose the hardcode, the Terraform version that you would like to execute. Okay, and then we are adding the Terraform cloud. So here we are providing TF, that is cloud cloud Terraform the Terraform API, that is TF API. If I can go to the environment, so basically we have kept some environmental secret here, right? That is a TF var file. Okay, so that is a TF API code. Okay, so I'm going to show you that is TF API token. Okay, so that's TF API token will be given here. So basically when you are setting a Terraform, pointing to that Terraform token, it actually helps you to get access to this your Terraform organization, and also to the respective workspace and etc. So I'm going to show you in details after when I walking through this code. Okay, so basically this is what, so basically this token will help you to get access to the Terraform cloud organization, especially organization. Okay, that's the first step. Yeah, then we will go to the next one. In the next command we are just invoking the Terraform, then we are validating the Terraform, then this is the place where we are actually doing the Terraform plan. Okay, so once the plan is succeed, okay, so once the plan is succeed, then only it will start to do a Terraform apply. While you are applying the Terraform apply, while you are executing the command called Terraform apply, we are doing -- auto approve. Okay, so basically once you have the plan ready, you are checking if the plan has gone success or not with using Terraform plan status check step. Once the plan is succeed, right, then we are actually invoking the command called Terraform apply -- auto approve. Yeah, so this is how the AWS TF apply.yaml file, which is a called workflow file, will be executed. the same thing is being replicated here, and it does not has the apply here. That's the only difference. Okay, everything steps remains exactly same. It is okay, and that's the reason, that's a specialization. Okay, so you declare your plan and you declare your apply only once, and you're gonna reuse it for your multiple components of your, to spin up or to manage the multiple components of your AWS platform. Okay, and that's what we call it as a platform engineering. Okay, all right, so that's the basic definition. I think it was very long, but yes, that is how the detailed, the information about the reusable workflow, which contains called and the caller files. Okay, caller and the call files. Yeah. Now I'm going to walk you through the what actually I'm doing. I'm going to show you how to spin up IAM roles in our AWS account. Okay, so that's just this thing that, scenario where you want to manage the roles on your AWS accounts or in your AWS account with using infrastructure as a code technology, with using GitHub Action, and Terraform. Okay, this is how you do it. As I was explaining, it contains this many file. I'm going to walk you through the first to the main.tf file. As name says, main.tf file. So this is the file where it declares the provider data, it declares the backend remote data, it also declares the Terraform provider data. Okay, so that's what I'm going to show you here. So you are creating a block called Terraform. In this one, you are provided the required provider. So here is AWS is my provider, and then you have a backend remote. Okay, so you also declare the backend called remote. In this one, you are adding app.terraform.io. What does this mean? Basically, this is the FQDN of Terraform Cloud. If you see app.terraform.io, okay, which is a Terraform Cloud FQDN or URL. And then in that one, I'm choosing the organization called my organization, that is cloudquicklabs. Okay, right. In that one, I have a workspace called AWS Backup and Azure Labs. Okay, so in this one, I'm interested in the AWS Backup because this is the AWS solution. Okay, and then finally, we are setting the provider default to the region US East 1. Okay, so that's the definition of main.tf file. I'm going to take you to the IAM file. So here, I'm not going to walk you through this file. So basically, this is the code I have written just to create IAM, AWS IAM role, IAM policy, and IAM role. So when I'm deploying when I'm deploying this resource creation in the environment, I need the name of my resource look like it should follow some naming convention belongs to the dev. When I release to the UAT, it should follow the naming convention belongs to the UAT. Okay, that's the logic here. Okay, so how I'm doing that? I'm doing that with using .tf war files, with using variable.tf file. So that's the logic here. If I go to the variable.tf file, in the variable, we are using the variable called role name. It is a type of string. Okay, and the same thing is been declared across the environment, like role name equal to UAT testing role. When it comes to the production, it names changes to production.testing role. When it changes to the development, the naming convention of the role is dev underscore testing role. Okay, and that's what been consumed here. Okay, so this is the resource which actually creates a AWS IAM role policy. It contains a name. You see that this is the name of this policy, right? And then if I, so basically I'm just keeping the name of the policy very static, and here it references the role. So this is the role. I'm going to show you how we can do this, and this is just a dummy policy definition. I will take you to the role. So while we are creating the role, we are giving the name of the role according to the environment. Okay, so as I showed you in the development, UAT and production, the role name changes. Okay, and that's what we see now. Okay, all right, so basically this is what I did. Now I have completely walked you through the from the scratch to end and how did I set up this one. Okay, now the time is for demo purpose. Okay, so for that case, what I do is I'm not going to synchronize any code. You can directly go to the GitHub Actions. So I will take you to the GitHub Actions, right? In the GitHub Actions, so if you go to the GitHub Actions, since we are using called since we are using caller and the called type of workflow, you can directly go ahead and invoke. Okay, so if I go here, so there is a button called run workflows. Okay, so this workflow has a workflow dispatch event trigger. In sense, it gets triggered whenever you want to. That's the reason you can do it. Okay, now I want to run it on the development. So if you remember, while I was explaining on the development, right, so we don't need any approvals. Okay, so basically development, you see, if you see follow the development, it is basically pointing to the branch name called feature branch 1. Okay, so that's what I'm going to do here now. So I'm going to point it to the feature branch 1, and it should automatically get invoked. Okay, so I'm going to just run it that. So once I click on the dispatch, or click on the run the workflow gets invoked, and we should see some instance being invoked here. So here you go, right? IAM roles is being invoked now. And if you click on that, right? So this is a very beautiful picture that you can see here, right? So when you use environment, that's where that's where you see this kind of diagram gets completed. Since the plan dev, right? Since the plan dev is the first step and the deploy dev is dependent on this one, that's the reason you see this pipeline gets automatically drawn, in the sense that that mark gets automatically drawn by the GitHub action itself. Okay, so basically the first step will actually run the Terraform plan, and once the Terraform plan is success, then only the deploy to the development gets invoked. Okay, and that's what we're going to see now. Basically it is actually actually doing some plan. If I show, if I can extend one thing, first one, we are setting the job, right? Then you are setting the checkout. Basically you are cloning the repository, and then you are changing the file name. Okay, this is where the magic happened. Okay, if I can open this one, earlier the file name was dev.tfr file. Now I have renamed it to I have renamed it to auto.tfr file. Okay, that's what it happened. Now you see the plan dev has succeeded, and it is now invoking apply dev or deploy dev, right? So I'm going to walk you through the plan. So I'm going to explain that. So if you see the plan definition, right? So you see it going to destroy two things and add two things. Since I'm using the same environment, so basically it does the it does the destroy and creates the resources. Okay, now we will go to the apply plan and see what is actually doing. Basically it follows the same step till plan, and finally it applies the Terraform apply. Okay, so while it is running, let me take you to the workspace as well. So I can go to the workspace. So this is Terraform cloud workspace, and we should see something running here. So I will go to the runs, and here we see the runs. Okay, so here you go, the run is in progress. Okay, you can also see the same logs from here as well, right? And also the same logs, the basically GitHub action and the Terraform cloud works parallel, and whatever happens here, whatever the logs been happen here will be mirrored here as well. Okay, so that's the beauty of this GitHub actions. Okay, now let's wait for a Terraform apply to get complete, and finally I'm going to show you that resource is being deployed into the AWS account. And we will also show you, how does it works when you deploy to the UAT, where we have configured the approval configurations. Okay, so basically it is actually creating, let's go to the IAM meantime. Oh, so since in this on this account we are actually creating what? We are actually creating the IAM roles here. Okay, that's what I'm going to show you here. And the role name should start with dev. Okay, that's the specialty. And when we are released to the UAT, the name should change. Okay, basically since I have a same account, it actually destroys and tries to recreate whenever I deploy to the respective environment. But when you have a different environment, what does that mean? In the sense you have different accounts. Okay, so in that case you don't have this destroy creating things, but in my case it happens. Okay, that's for your note. So here basically it has created the infrastructure, so we can see that from here, right? So it has actually created a role with the name something like this. Just copy this, and I'm going to take you to the role and check if the role is being created, a dev testing role. Okay, so basically I'm going to say refresh it. Here you go, the role is ready. Okay, so role is being created. Okay, all right, so basically this is how the infrastructure works. Now finally I'm going to show you, if I can refresh here. So here also glean. Okay, plan is finished or apply is finished, basically. Yeah, now I'm going to show you one more thing, that is how does this workflow behaves when you run on the UAT environment where actually approval is there. Okay, so UAT environment is nothing but it is been pointed with using branch name called main. Okay, so I'm going to run that. So why did I do this? I have explained a reason. Okay, so because when you want to release to the protected environment like UAT and production, you have to run with tested code, not a developed code. Okay, so the code you should not run under development code. Okay, so that's the reason workflow has to be dispatched with using the branch basis. Okay, that's the aim behind this one. Yeah, so if I open this one, it actually does the same job, but here if you see it has not yet started the plan. So let me scroll down. So currently in the plan UAT, it is actually planned, but you see here it has still waiting. It has not started to run the Terraform plan, but it is waiting for my approval. Okay, so I'm going to approve this one, saying like approved. All right, so basically your manager does always approved. All right, so that's what I'm doing here. I did the approved. Okay, and when I click, when I go to the UAT, so basically it now I have approved the GitHub action to initiate the Terraform plan on the UAT environment, which I think protected, very protected environment. You need to keep everything clean and safe there. Okay, so that's the reason it passes through the approval, because the approval will see if something is going right. Whatever you are releasing to the your environment is already tested or not, is the right thing is going into the environment or not. So that's the point. That's the place where you actually control that. Yeah. So I'm gonna wait for this to get complete. So basically what it happens is, here since I am using the same environment, now this role will get renamed into UAT testing. Okay, so that's what the magic happens. We just wait for it, and I'm going to show you that the dev role will get destroyed, and the UAT role gets created. Okay, all right. So looks like our plan has been done. So I'm going to walk you through this plan. And here you go, right? So the plan is ready. If I go down to the plan, it says you are going to destroy 2 things and add 2 things. Okay, yeah. So again, the magic is here. For every step it will ask you for the review. So the deploy to the UAT or apply the action on the UAT is still waiting for my review. Okay, so I'm gonna approve it now by commenting approved. Okay, so I will just click on the approved. Yeah, and then it starts to run the apply. Okay, so that's the advantage of using environment. Okay, so here where you can control the deployment on your environments. Okay, and also it provides an add-on advantage that it will also give an opportunity where you can store your secrets. Okay, secrets belong to the respective environments, and secrets are being secrets are being reciprocated or passed on the internet with a very secure mechanism, which is followed by the GitHub Actions. Okay, it's very safe, very secure. You can use the GitHub Action environment to store your secret. Okay, all right. Now basically we just wait for old destroy and create a new role. Okay, so and finally that's the end of our demo, and let me wait for this to get complete, and that will conclude our demo finally. Okay, all right. Anyway, so whatever the code file structure, whatever the folder file structure, whatever the code files I have showed you, I'm going to create a bundle of that, create a separate folder of that, and I'm going to paste it under a separate dedicated repo where I will share generally, and that repo link will be shared in this video's description. You can find it from there and try to replicate the same scenario when you are trying to learning from my videos. Okay, all right. So finally we are in the Terraform apply. It's actually running. If I can go back to the runs, we should see some running here. Okay, again, so here you go, right? It's currently running something. Yeah, basically plan is running, and it's apply is appending. So apply is pending is basically it's synchronizing basically. Yeah, so I'm gonna show here. So now we should see apply should be running, right? So apply, yeah, here you go, apply is running. Since I have added auto approve, it will automatically start running. Yeah, so we don't need to worry about that. So here you go, the approve is approve, the apply is running here. Whatever we can see from this console can also be seen from there. Yeah, and here you go. So it has told that it has successfully created a new role. Okay, I'm gonna copy this. Yeah, so basically what we did here is we have remotely executed our Terraform file in the Terraform cloud, and also our Terraform state file is now safely stored in the Terraform cloud, and the Terraform cloud is responsible for managing the lifecycle of those Terraform state file very safely. All right, so now let's go to the IAM role and try to find the role now. So I'm gonna copy paste that same role. If I refresh, we should not see this role. I'm gonna, because it is already destroyed. Okay, so here you go, the role is destroyed. Now I'm gonna check with UAT, and here you go, the UAT testing role is appeared now. It has just now created. Okay, all right. So I have successfully shown you the things to be shown in this demo. Finally, a kind request, please do subscribe my channel. That would really encourage me a lot. So with that note, thank you, thanks a lot, and see you in the next video.